Hello, hello, and hello. Welcome to Pi Smash, the YouTube channel for Python tricks, tips, and tutorials. So, let's get the ball rolling. And everyone,
Brace yourselves!
so today we are gonna learn about something called the LAZYPREDICT. So, what does LAZYPREDICT library actually do? So when we have a data set with us, we first check about the attributes and how it's actually distributed, the mean variances and the stuff like that. But what comes next is the data science problem. And in maximum cases we see it's either a regression or a classification problem. But the problem is there are so many models that can actually fit into the data, but some models fit a data quite well and gives a higher accuracy or precision for that matter. So here comes LAZYPREDICT. So what LAZYPREDICT does is that it takes in the data and puts it across a variety of models and gives its output on the basis of RMSE or its accuracy scores, and just formulates it in form of a table, and on looking at the table we can actually see which model would be actually be best for the data. So let's get into it. So here we are to our humble Google Colab. So first what I thought is I would do the classification first and then I would go ahead with the regression. But first I need to install this LAZYPREDICT in our Colab machine. So I need to install the LAZYPREDICT with pip install LAZYPREDICT, and I pre-installed it just to save some time. Then I imported the lazy classifier and imported the breast cancer dataset from sklearn. Soon after that I did the training test split of the data, very generic, and then splitting the data and fitting the model on this data. And soon after that I get a list of these models arranged on the basis of accuracy. As you can see, linear SVC, perceptron, logistic regression, XGBoost classifier, support vector, and so on. So this gives everything under one table based on your accuracy, balanced accuracy, also you see F1 score, time taken. So you can get everything under one table. So that makes our job a lot easier for us. We do not need to write separate codes for each and every model and then compare. So next we move on to the lazy regressor, and similarly we do the stuff as we did in the classification. So it's more or less the same thing except the part that we have loaded the Boston data. It's also a very common data set, and with the help of this data set we try to fit the model on this data. And similarly, in case of regression, we get support vector regression, XGBoost regressor, NUSVR, random forest regressor, gradient boosting regressor on the basis of R squared, RMSE, and time taken. So this also gives a very detailed table which shows which model actually is giving the highest of the R squared values, so we can get a brief idea of which model will actually be beneficial for us. So all in all, I believe that this library is actually quite beneficial for data wranglers like us, as it saves a lot of time, effort and code to check different models on the basis of their RMSE or their accuracy scores. So that's it. That brings to the end of our video. If you believe that this video was beneficial to you, please do give a like, share my video to your peers, and subscribe to my channel. Follow me for more updates on my Instagram, and see you on the next one.
I gave you my heart.